Here are the answers to problems 12, 13, and 14. These are all ramp problems. We want to make sure that we have our forces drawn correctly. The normal force is up at a bit of an angle because we're slanted. Force of friction goes up the hill. Gravity parallel is going down the hill. Gravity perpendicular is going sort of into the hill. Don't forget that we're breaking our force of gravity into its two components. And that's going to allow us to make this a very easy right equals left and up equals down problem because this object is not moving. So if we take a look at the right and left, I know that my right arrow, force of gravity parallel, which we have an equation for, it's the sine of the angle times mg, is going to equal my left force, which is force of friction. So sine of 20 degrees times the mass 7 times 9.8 gets me 23.5 newtons. And since that's to the right, friction must equal that going to the left. Same thing is going to hold true for up and down. My normal force up is going to equal my force of gravity perpendicular down. So normal up equals perpendicular down. Force of gravity perpendicular is the cosine of 20 times the mass times 9.8. So cosine of 20 times 7 times 9.8 is 64.5 newtons. In problem 13, we now are pushing it up to the left with a force of 35 newtons. Force of gravity parallel goes down the hill as always. Gravity perpendicular goes into the hill as always. Normal force is up out of the block as always. And because I'm pushing it left and there is friction, if it's sliding left, friction must be going to the right. We're trying to find what friction is. So if we take a look at my right and left forces, all the forces that go to the right equal the ones that go to the left, which means gravity parallel and friction. Gravity parallel plus friction has to equal my force of pull left. So gravity parallel plus friction equals force pull left. And I'm trying to solve for force of friction. So if I'm trying to solve for friction, I got to get gravity parallel out of there. So I subtract it over to the right side. That leaves me with friction equals the force of push minus gravity parallel. We know the force of push is 35. That's right here. Gravity parallel is sine of 25 times the mass 5 times 9.8. Plug that into your calculator and you know the friction has to be 14.3 newtons. Up still equals down, so normal still equals gravity perpendicular. So normal equals gravity perpendicular here. And gravity perpendicular is still the cosine of 25 times 5 times 9.8, which is 44.4 newtons. Finally, number 14. Now we're trying to solve for the force of push going up the hill. We can solve for gravity parallel with the equation for gravity parallel. We know friction is 20. And so if we do right equals left, we were only being asked for the force of push. We weren't asked for the normal force. If we wanted to solve it, we could, because normal is still equal to gravity perpendicular. But right equals left, gravity parallel plus friction, here they are, equals force of push to the left. Solving force of push, I don't have any algebra to do. Gravity parallel is the sine of the angle times mass times 9.8, so that's 10 times 9.8, plus friction, which was given at 20. Add those two together, and you find the force of push is 76.2 newtons.